Welcome back again. We are proceeding for our next session, and for this session we have Rajesh BODKHE sir. I welcome him. Uh, Dr. Rahul BODKHE sir is currently working as assistant professor in the Department of Mechanical Engineering, Yeshwantrao College of Engineering, Nagpur, Maharashtra, India from 10th June 2008 to till date. He completed his education from RTMNU, PhD in Mechanical Engineering in 2025, MTech in Heat Power Engineering in 2007, and BE in Mechanical Engineering 2002. He has total of 22 years of teaching experience. He taught various subjects to undergraduate students like engineering, thermodynamics, renewable energy system, and fuel cell technology, etc. He guided more than 50 undergraduate students. He has more than 12 research publications in scope of index, conference proceedings, book chapters, journal, as well as science journal on his PhD research work. His research interest area is a solar power hydrogen fuel cell system. He worked on active hydrogen PEM fuel cell as well as passive direct ethanol fuel cell. He worked in a Synergy Fuel Cell India Private Limited, Chennai, where he used Synergy Fuel Cell Laboratory for his research experimentation on active proton exchange membrane fuel cell and implemented his research knowledge to save the electricity. He worked on design, development, and performance analysis of the polymer electrolyte membrane single fuel cell of MEA size 25 square centimeter using hydrogen fuel to check its performance in terms of cyclic voltmeter, electrode impedance spectroscopy, analysis of single fuel cell using electrochemical software. He worked on proton exchange membrane electrolyzer which produces 50 cc per mm hydrogen. He is involved in various departmental level and institute level portfolios. He is a faculty advisor of YCC team accounts. Under his guidance, students secure AIR number 1 and won the prize of about Rs 1.78 lakh in two national level electrical kart championship competition, NEKC and BFKCT competition in 2019. Team Hacker secured AIR 2 in ITR in 2024. He is a departmental in charge of industry internship and developed the relationship with about 50 plus industries in Hina and Dutiburi MIDC for students, which is projects, training, internship, and placements since last 15 years. He provides the support to BTech 8 semester students to get their training and semester long internship in core industries like Mahindra, TASL, Kinetic Gears, GMG Technotrades, Novasis, Dinergy, etc. He conducted many industrial visits for students and faculty. He is a startup designated partner. ERYY Technology Solution LLP under Technology Business Incubation Section, 8 companies at YCC. So, as a token of respect and appreciation, let's give a warm floral welcome to our guest. For that, I would like to call Barbade sir to welcome our guest, Dr. Rahul Vakmare sir. Rahul, sir, Rajesh BODKHE. Thank you, sir. Now I would like to Dr. Rajesh BODKHE sir to conduct the session. Thank you, sir.
Thank you, sir, for a brief introduction. And thank you for giving me this opportunity. So I understand this is post-lunch session and this is last session. So I understand your situation. So we try to compress the session. Okay, I have a lot of slides, but I will not show every slide. We will, you know, we will try to conduct this interactive session. So all faculties from Polytechnics, Ma- Maharashtra state or other state also? Only Maharashtra. Only Maharashtra. All from mechanical engineering? Yes. Mechanical civil. Okay, great. Who is from civil engineering? Civil. You are from civil. Other from mechanical engineering? Yeah. So nice to see you all. Already the introduction was given by Professor, and it's my important privilege that I'm here in front of you to explain about fuel cell, and it's a future of green power. So, how many of you know about the future of this green power and fuel cell? Any idea about fuel cell? So this fuel cell is electrochemical device actually, and which converts this chemical energy to electrical energy. So if you see this diagram, so here in this particular type of fuel cell, the H2 splits, that hydrogen splits at the anode catalyst. Okay, and this you can see here, this point is there. You can see this H2. You can see this H2 splits at the anode catalyst. So this membrane, this is a polymer electrolyte membrane. So I'm talking about the polymer electrolyte membrane fuel cell. This is also known as proton exchange membrane fuel cell. So I am focusing on this kind of fuel cell because I have done research in this area in last 7 years. So basically, when we use these um, pure hydrogen, so here you can see there is only water at the cathode catalyst. So there is no other byproducts, only water and heat along with the. So you can see uh, at uh, at this membrane, only this protons allows towards cathode catalyst, whereas the negative electron pass through the DC electronic load and it is met at the cathode catalyst. So the half reaction takes place at the anode catalyst and the half reaction takes place at the cathode catalyst. So this is possible when you use hydrogen fuel in the fuel cell. This is just a schematic view of the fuel cell, PM fuel cell. So you can see the different types of fuel cells is available. So depends upon the um, temperature, depends upon the temperature requirements. So I have worked in this area, PMFC active as well as DFC passive. So I have done the experimental analysis between DFC and PMFC. So this PMFC analysis I have done at Chennai Sci Energy Laboratory in collaboration with IIT Madras Research Park. So whenever you get the time, you can visit. If you really want to do the research in this area, you can visit IIT Madras Research Park. So Dr. Balaji is there. So I will give his number. He's my very good friend, and you can see there are 7 to 8 laboratories where only the people working on PMFC, active PMFC. They right from development of membrane to assembly. So there is no option because as on date we are using electric vehicle. So people are using electric vehicle, but there is a um, problem of battery. So you can't purchase electric vehicle if you want to go say Aurangabad or Pune. So you are going by only petrol vehicle or diesel vehicle. So you will not prefer electric vehicle. That is only if you are preferring for city. So there's a problem of charging also. If you compare with the electric vehicle. So here in fuel cell, continuous fuel is required to produce the electricity. So that's why this will be used in future. And as on date, it is using in various applications. Okay, so you can see this SOFC is using for stationary power, that is in power plants. Then MCFC is using in large scale power production. AFC is using already it is using Apollo mission. Then PFC is used in commercial power application. So here I am focusing on this. We have developed this PM fuel cell inside energy laboratory, and so this is single PM fuel cell. So with single PM fuel cell, you can produce hardly 15 to 25 watt electricity. But when you want to produce more electricity, you need to connect number of fuel cell in series. Because when you want high voltage, we need to connect number of fuel cell in series. So this is just single fuel cell assembly. So we have I have done the internship there inside the laboratory, and we have developed 500 watt fuel cell. So that fuel cell can give the lighting. Means you can what this laboratory you can just give the power to these four fans and then light by using 500 watt fuel cell is sufficient. PM fuel cell is sufficient. But as on date, the cost matters. Cost is very high. Cost, it is very costly affair actually. So if you see this PM fuel cell is a thin, solid or organic compound type, typically the consistency of plastic wrap and about as big as 2 to 7 sheets of paper. Okay, so this membrane, function as an electrolyte. Electrolyte again plays a very important role. So in that membrane plays a very important role. Membrane you can say is the heart of this fuel cell. Heart of fuel cell. So this is just design we have done for single PM fuel cell. This is very important part of the fuel cell because it is the heart of fuel cell and responsible for the electrochemical reaction. So here this catalyst loading at anode side as well as cathode side is very important. People are doing research. So rigorously they are doing research. Many people are, researchers are doing PhD. They are PhD in this area. They are just producing this membrane and just they are changing the loading. So I have used this based on the research paper. I have used this 20% platinum lithium, and on catalyst cathode I have used 55% platinum on high surface. So researchers are changing this. Some researchers are taking 60% on anode side and 40% on platinum on the cathode side. So based on the composition gives the best result, that matters. That matters. So based on the various experimentation, you can understand those are composition अच्छा result दे सकता है. And you can make this membrane. However, this membrane is procured from Sai Energy Fuel Cell Private Limited. But even in Nagpur also we have a laboratory in RT menu where we can prepare this membrane. We can prepare the membrane. Again, one thing I would like to tell you that the size of the fuel cell also matters. So this is now we want to choose the active area that is 25 centimeters square. So you can change the active area also. Any active area you can change. You can change the size. I have choose rectangular shape. So membrane I have choose square. You can take circle. So that size also matters. So based on the research, if you go through the research paper, you can get the idea, and those really want to do the research in this area. That's why I'm telling. You can take this topic and you can start your research work in this area. That is fabrication of a membrane alternative to Nephron membrane. Because as of that, Nephron membrane is only available in the market to generate the electricity. And many researchers are doing the research, and main thing is the catalyst material. So platinum is very costly affair as of now. Then this was my experimental setup. that is available in Psi Energy Laboratory, and we have developed the 5 centimeter by 5 centimeter MEA, and we kept here that MEA. So before going to this, before going to send this fuel to the fuel cell, it should pass to the humidifier. It helps to increase the enhance the efficiency of the fuel cell. So here we can change instead of we can change supply instead of air we can use oxygen also. So oxygen and here fuel is hydrogen. So we can regulate the pressure. So initially we just start with sending the fuel and air at say 0.5 megapascal, and just we check check the behavior of this fuel cell, how it is behaving. So there is a complete data acquisition system where we can set the where we can see the voltage, where we can see the current, and uh, we can see the power, and you can also get the calculated value through this data acquisition software. So this software is available in Psi Energy Laboratory. So just you have to develop your own fuel cell according to the research paper, whether you want to develop circular, whether you want to, what type of composition you want to take in respect to membrane. So that I told you that I have taken 80% catalyst loading on anode side and 55% catalyst loading on cathode side. So you can change the loading. Even the layers also you can change, whether you want to take 2 layers, 3 layers. So that also matters. So ultimately, there should not be fuel crossover. There should not be fuel crossover because if you see, if there is a crossover, it affects the fuel cell efficiency. Theoretically, the efficiency of the fuel cell is about 83%, and in actual practice also it is about 45 to 50%. It is more than ICNG. It is more than ICNG. So here, sorry. So here we can set the hydrogen gas, we can set the temperature, humidifier, temperature. This complete experimentation is based on your values. What design of experimentation you choose? So I just choose from right from I choose the temperature values, like 50, 60, 70 degrees centigrade. So you can choose 55, 65, 75. So this PM fuel cell works with maximum. It is works better up to 80 degrees centigrade. So you can change the temperature. Like you can start from 45 degrees centigrade, 45, 55, and 65 degrees centigrade. So like that you can change the value. So for every set you can get the different readings here. So you can see this is just initial starting. You can do the testing, static testing, dynamic testing, and you can activate the fuel cell. So this is a very good software that developed. It is connected with this uh, fuel cell. So here, this kind of fuel cell we have developed is just single fuel cell assembly of 32 centimeters square MPa. 32 centimeters. And there are different types of fuel cell where we work up to 500 watt fuel cell. So this is a complete fuel cell test station. In Nagpur, we have semi-fuel cell testing station at RT Avenue. Those from Nagpur, they can visit to RT Avenue laboratory and they can start your research experimentation. It doesn't matter that you only want to start a research, PhD research. You can, if you want to write a research paper also. So if you want to write the research paper, you need some experimental data. Okay. So without experimental data, you cannot get the graphs. Okay, you cannot do the analysis. So many researchers those already completed their PhD, those going for postdoctorate also. So you are most welcome at RT Menu Laboratory. Those are from Nagpur, and you can do experimentation on membrane, application of membrane. So again, there are a lot of papers are available on the membrane. You can search on the internet. So this is the research laboratory. So you can see the different fuel testing stations are available for different wattages. So here, say this is for 100 watt, this is 300 watt, and 500 watt. So up to maximum 500 watt we can go here in this laboratory, and you can see this light, this power is this complete laboratory is running based on this fuel cell, EM fuel cell. Yeah, and also I have done this I have done some addition in this laboratory. I have made this laboratory to solar energy. So we have installed solar panel on the rooftop, and we have done this fuel cell testing station using solar energy. So ultimately, you are saving the energy because as just session is completed by this round, and we talk about the solar energy. So you know the all importance of solar energy. So nowadays the people are using solar panels on their rooftop, and they are saving the electricity bill. So ultimately, if you see monthly, you will get around 5,000 rupees per month electricity bill. So it is about 60,000. You are paying every year 60,000 rupees. So if you are installing one time 3 kilowatt for one family 3.3 kilowatt is sufficient. So ultimately, in 3 years, you get your money back, and from fourth year, it is free. Electricity will be free. So many people now installing the solar panels on their rooftop. So we have also installed a solar panel for this particular complete lab. So I have done the experimentation. So I have installed a solar panel for running this fuel cell testing station. So because my topic was solar powered, so that's why I have to run this fuel cell testing station using solar power. So that was a requirement. Then we have also developed in our own laboratory in my college, ICC, Yeshwantrao Chauhan Polytechnic in Nagpur, this kind of fuel cell. So this is direct ethanol fuel cell. So where we can use instead of hydrogen, ethanol we can use. So because we will see the about the hydrogen infrastructure. So this fuel cell uses again we have developed the fuel cell of 50 mm, 50 mm by 10 mm and volume of 25 mm. So for this fuel cell we have done the rigorously testing. How we have to do the testing? The main thing is voltage. So to check the voltage we use DC electronic load. DC electronic load where we can set the resistance and just any from right from 2000 ohm to 0.1 ohm. So we started from 2000 ohm and we set the resistance say 1000 and 500 and 400. So for every set of resistance we get the different values for different composition. So here is in this reservoir we just fill the ethanol along with the water. So there is a different combination. We made prepared the different combination of ethanol with water. So different concentration, right, from 0.5 molar to 5 molar, 0.5 molar, then 1 molar, 1.5, 2 molar. So you can change, it depend upon your strategy, your methodology, which experimental methodology you choose. So based on the research paper, I have choose this research methodology that I have choose the concentration initially 0.5 molar concentration, then 1 molar concentration. So initially I just feed the concentration of zero point 0.5 molar. Then I start the experiment and then I just start to measure the value of voltage and current. So again, I repeat the procedure from 500 to 2000 ohm to 0.1 ohm, and we get the various number of readings for every composition, for every concentration, like 0.5 molar, then 1 molar, 1.5 molar, based on research papers. So you have to, what I mean to say, it is not possible to explain in 1 hour. So what I mean to say, what research topic you are choosing. So based on the previous research paper, there should have some base of the previous research paper, you have to go through the those want to do PhD research or those want to who already PhD they know very well. Um, so जिनको मतलब PhD करना है आगे जिनकी इच्छा है तो वो अ, जो रिसर्च पेपर है पुराने रिसर्च पेपर अगर आप अपने जो भी आपका टॉपिक चूज करते हैं आप जैसे फॉर एग्जांपल यू आर चूजिंग डायरेक्ट इकोनॉमिक सेल सो आई एम रेडी टू हेल्प यू इन दिस एरिया. So fortunately, I am the supervisor also in RTM, registered supervisor. So I can guide you how to do the experiment and I have choose 25 centimeter square area. You can use 50 centimeter square area. Um, I told you that we can change the membrane because this is removable. This membrane, this assembly is removable. You can just remove this nuts and you can insert the membrane. So different type of membrane you can test here in the assembly. So once your assembly is ready, you can test your membrane. And believe me, as on date, membrane research in membrane is very challenging. That's why this technology is not commercial scale yet. Because platinum की cost बहुत ज़्यादा है. प्लैटिनम की कॉस्ट बहुत ज़्यादा है और अभी फिलहाल प्लैटिनम कैटलिस्ट ही अच्छे रिजल्ट दे रहा है. ठीक है. तो रियली इफ यू वांट टू रिसर्च सो यू कैन work on the membrane and you can use that membrane in this assembly. So first of all you have to prepare the assembly, which specification you want to choose, whether 5 centimeter, whether 5 centimeter, 25 centimeter square or 50 centimeters square. Depends upon your research paper. Depends upon what kind of specification you are choosing. So this is just actual DMC development we have done at our laboratory. Then what is the advantage of this fuel cell? What is the advantage of this fuel cell? As I told you, high efficient, zero or no emissions. Then is क्वाइट ऑपरेशन. जैसे आपने देखा कि हम लोग सभी गाड़ी चलाते हैं तो जैसे गाड़ी चालू करने के बाद गाड़ी का आवाज आता है, इंजन का आवाज आता है, साउंड पोल्यूशन इज देयर बट देयर इज नो पोल्यूशन. No pollution in terms of sound, in terms of exhaust. Is you are using ethanol, so almost CO2 is there at exhaust along with water. But we can use ethanol because we have a lot of potential in India. Biomass is available, so it is modular, it is scalable. Renewable hydrogen integration is possible. Looking to the application, we can use this fuel cell in terms of hydrogen cars, buses, trains, ships, stationary power application, portable devices, grid integration. This is challenging area in the fuel cell system. So here you can see as the previous speaker talk about this solar energy. So we can use this solar energy to run this electrolyzer. So as I showed you the PM fuel cell, so you can just use it like reversible. You can say reversible PM fuel cell, or you can say just you can change the connection of that PM fuel cell, so you can make it a electrolyzer. आप PM fuel cell को electrolyzer बना सकते हैं. Means the same assembly, from the same assembly you can produce the hydrogen. So what I have shown you the previously, the assembly, that is PM fuel cell assembly, single PM fuel cell. From the single PM fuel cell, you can just change the connection and you can produce the hydrogen. So in case of electrolyzer, the hydrogen is produced at the cathode and oxygen is produced at the anode. And as we have seen in case of fuel cell, the hydrogen is split at the anode catalyst. In case of fuel cell, so it is split at the anode catalyst, and the membrane only allows the hydrogen ions towards cathode catalyst in case of PM fuel cell. But here you can split the water. So water is very important. pure water is required. There should be pure water to produce the hydrogen uh, at the cathode. So might be you studied electrolysis process. So it is a very popular. Hydrogen is producing through various sources. So for particular producing the green hydrogen, this setup you can develop. If you want to work in this area, you can develop the setup like this. And you can use this electricity from solar panel and you can store the green hydrogen here in the water. So metal hydride cylinder is required to store this because the hydrogen pressure is very high. It is about 700 bar. And we are using only 0.5 to 5 bar. So in our experiment, we have used up to 2 bar. 2 bar. So depend upon your what type of experiment you are doing. So I have done laboratory experiments. So it is very dangerous. You know, hydrogen is very dangerous gas. So this kind of setup you can develop at your laboratory. You can prepare the research proposal and you can submit to the DSP or various funding agencies, and you can ask for this kind of proposal. And you know, government is giving the funding to this area, particularly fuel cell and electrolyzer. So, Government of India already started the initiative in 2022 for developing this kind of infrastructure. So, I told you that the same fuel cell I have now used as electrolyzer, where this produce around 50, 50 ml, 50 ml per. Its capacity is very small, 50 ml per minute, 50 ml per minute. The same fuel cell I have used for producing the hydrogen. So you can think to develop this kind of setup at your level. So this is not costly. This is hardly 3 lakh rupees maximum. 3 lakh rupees. So if you have this kind of setup, you can develop. The cost of this fuel cell is about 30,000 rupees. 30,000 rupees. This is just 5 centimeter by 5 centimeter area. If you increase the size, then cost will increase. But once you develop this setup, you can check the hydrogen production, and you can write the research paper. But this setup should now in our later. Then it is possible. So this is available at Sai Energy. So now coming to the hydrogen potential, as we said that we will have a lot of potential which can be produced through the natural energy, which can be produced through solar energy or wind energy, and these byproducts from steel mills, chemical plants, for biomass also, and it can be used in the fuel cells. Particularly, the purpose is for running offices or hospitals, schools, or trains and vehicles, mainly vehicles. Because we have seen, as on date, the major pollution contributing by vehicles and industries. And it's a need of an hour that government has to think on this, because electric vehicle is the short-term solution. Only single system cannot do, I think. Hybrid, we have to go for hybrid. We have to think for hybrid solution. Single system is not efficient. There is a limitation of battery, because मैं अगर आज सोचता हूँ कि मुझे इलेक्ट्रिक व्हीकल लेना है, अगर मेरे पास ऑलरेडी व्हीकल है, 4 व्हीलर पेट्रोल व्हीकल है, तो मैं इलेक्ट्रिक व्हीकल अगर मुझे सिटी में घूमना है, लेकिन मेरे पास अगर 4 व्हीलर नहीं है, तो मैं पहली जो मेरी व्हीकल है वो मैं पेट्रोल लूंगा, या मेरा अगर ज़्यादा रनिंग है, 200 किलोमीटर रनिंग है, तो मैं डीजल व्हीकल को जाऊंगा, अगर मेरा पर डे रनिंग 200 है। लेकिन मेरे पास अगर पहला व्हीकल है पेट्रोल या डीजल, तो मैं इलेक्ट्रिक के बारे में सोच सकता हूँ। इसके लिए मुझे मेरे घर पे सोलर पैनल इंस्टॉल करना पड़ेगा, तो और आसान हो जाएगा, मेरी इलेक्ट्रिक बिल भी मेरा सेव हो जाएगा और मैं मतलब अच्छे से एंजॉय कर सकूंगा, राइट। तो अभी सिटी के लिए वो फिजिबल है, पर्टिकुलरली जो लेडीज के लिए तो बहुत ही अच्छा है, जो सिटी में ड्राइव करते हैं, हाँ इनका 15 से 20 किलोमीटर अगर आप रनिंग है रोज का, मैक्सिमम 30 किलोमीटर, तो बहुत ही अच्छी बात है। लेकिन लॉन्ग टर्म के लिए आप देखिए, आप अगर दिल्ली साइड अगर गए होंगे या मुंबई, आप देखिए आपको इलेक्ट्रिक व्हीकल काफी कम मिलेगी, जहाँ पे भीड़ है, जहाँ पे भीड़ है, जहाँ पे ट्रैफिक ज्यादा है, वहाँ पे आपको इलेक्ट्रिक व्हीकल नहीं दिखेगी, अगर आपने मैनुअली ऑब्जर्व किया होगा तो। क्योंकि प्रॉब्लम वही है, बैटरी डिस्चार्ज, जितनी ज्यादा समय आपकी गाड़ी खड़ी रहेगी, बैटरी डिस्चार्ज भी साथ में होगी। नागपुर में आपको इलेक्ट्रिक व्हीकल दिख रही है क्योंकि नागपुर में उतना ट्रैफिक नहीं है आज मुंबई के कंपैरिजन में या दिल्ली के कंपैरिजन में, वो वहाँ पे फिजिबिलिटी है। जैसे बेंगलोर में उन्होंने फ्रेंचाइजी दी है, जगह जगह पे चार्जिंग स्टेशन ओपन किए हैं, तो वहाँ पे इलेक्ट्रिक व्हीकल फिजिबल है। लेकिन वी हैव टू थिंक फॉर हाइब्रिड सॉल्यूशन नाउ, next 10 years, next 20 years, we will think for FCV. FCV. Then you can see the fossil fuels dominate the world energy complex. यहाँ पे जो contribution है, आप देखिए global energy का जो contribution है, nuclear hydro में 16%, nuclear में 11%, oil 5%, natural gas 22%. कोल में सबसे ज्यादा। आज भी हमारे जो थर्मल पावर प्लांट्स पे जो नागपुर के हैं, जो बोराड़ी थर्मल पावर प्लांट है, वो हमारा एक सोर्स है इलेक्ट्रिसिटी का। यहाँ से 45% इलेक्ट्रिसिटी हमारे मराठवाड़ा में जाती है। जैसे हाइड्रो इलेक्ट्रिक पावर प्लांट है कोलकाता में, 55% हमारे महाराष्ट्र में आती है, 45% हमारे मध्य प्रदेश में इलेक्ट्रिसिटी जाती है। तो आज जो मेजर जो इलेक्ट्रिसिटी प्रोडक्शन हो रहा है वो कोल हो रहा है। तो आज देखिए कितना, आप अगर थोड़ा सा ऑब्जर्व करते हैं बोराड़ी में जो चिमनी लगी है वहाँ से कितना पोल्यूशन हो रहा है। जहाँ जहाँ भी पावर प्लांट्स है, जैसे जो लोग चंद्रपुर साइड के हैं, देखिए कि उस एरिया में कितना पोल्यूशन हो रहा है। तो ये भी हमको इसके बारे में सोचना बहुत जरूरी है। फ्यूल सेल बैकअप पावर के लिए आज के लिए बेस्ट अल्टरनेटिव है, क्योंकि यहाँ पे स्टार्टिंग में बैकअप पावर के लिए बहुत सारी ऑक्सिलरीज हैं पावर प्लांट में। अगर आपने विजिट किए पावर प्लांट देखा है तो वहाँ पे बैकअप पावर के लिए, जैसे आज हम देखते हैं जनरेटर्स यूज करते हैं, तो हम जनरेटर को रिप्लेस करना हमें बहुत जरूरी है। बहुत सारे कॉलेजेस में आज जनरेटर्स लगे हुए हैं जहाँ पे वो डीजल पे रन हो रहे हैं, तो उसको भी रिप्लेस करना बहुत जरूरी है, क्योंकि अल्टीमेटली डीजल से नॉक्स जो प्रोड्यूस हो रहा है वो डायरेक्टली हार्मफुल है लंग्स के लिए, उसका इफेक्ट होता है लंग्स के ऊपर, और लंग्स अगर डैमेज हो गए तो आपको पता है क्या होता है। तो हम इंडिया में उतना मतलब अभी गवर्नमेंट ने इनिशिएटिव लिया है, 3 साल से काफी मिशन चल रहा है। फॉरेन कंट्री में दे आर वेरी अवेयर अबाउट द पोल्यूशन, तो वहाँ पे स्क्रीन्स लगी है जगह जगह पे स्क्रीन। हमारे नागपुर में भी ऐसी स्क्रीन्स लगी है, वहाँ पे वो दिखता है कि कितना CO2 प्रोड्यूस हो रहा है, कितना नॉक्स प्रोड्यूस हो रहा है। हम मतलब जो लेमैन है उसको क्या समझेगा, हम इंजीनियर्स हैं तो हम एक सजेशन दे सकते हैं कि जो आज एफडीके हो रहा है इसके दौरान इतना एक मैं मैसेज देना चाहता हूँ कि एक अवेयरनेस, गवर्नमेंट अवेयर है लेकिन लोगों को भी अवेयर करना बहुत जरूरी है। क्योंकि आज हम घर से ऑफिस में आने के लिए निकलते हैं तो वहाँ पे देखिए कितना जो लोग 2 व्हीलर चलाते हैं पर्टिकुलर, अब मतलब एक शर्ट दूसरे दिन नहीं पहन सकते, कितना धूल होता है रास्ते पर, कितना पोल्यूशन बढ़ चुका है। जो हमारी मतलब जो हमारी एनर्जी लेवल है मॉर्निंग में बहुत अच्छी रहती है, लेकिन इवनिंग में हम डाउन रहते हैं, तो बिकॉज ऑफ दिस पोल्यूशन, बिकॉज ऑफ एटमॉस्फेयर। ठीक है, जो ऑफिस का वातावरण है उसके कारण तो इफेक्ट होता ही है बॉडी के ऊपर, लेकिन पोल्यूशन सबसे बड़ा कॉज है, पोल्यूशन सबसे बड़ा कॉज है। अब ये जो टेक्नोलॉजी है इसमें अगर इसको पूरा कंप्लीटली तो पॉसिबल नहीं है, 2050 तक आई थिंक गवर्नमेंट ने बोला है कि 2050 तक पूरा जीरो पोल्यूशन जीरो हो जाएगा, तो क्योंकि कुछ लिमिटेशंस भी है। देखिए आगे तो क्या लिमिटेशन, क्या फ्यूचर प्रोस्पेक्ट्स है? तो फ्यूचर प्रोस्पेक्ट्स क्या है? फॉलिंग हाइड्रोजन प्रोडक्शन कॉस्ट, green that you have seen, that green hydrogen is produced from solar, wind. Then this fuel cell already it was used in aviation and shippings. Then we have seen that schematic view of integration with renewable energy microgrids. So particularly in remote areas. So where in remote areas where grid is not possible, where जहाँ पे इलेक्ट्रिसिटी टावर्स नहीं है, वहाँ पे फ्यूल सेल्स आज काम कर रहे हैं। तो यहाँ पे इलेक्ट्रिसिटी बहुत सारे ऐसे हमारे इंडिया में ऐसे कुछ एरियाज है जहाँ पे आज इसकी तो आगे देखिए कि कितना पोटेंशियल है ग्रीन हाइड्रोजन का। गवर्नमेंट ने जो इनिशिएटिव लिया है 3 साल से, तो ये इतने सारे स्टेट्स में ग्रीन हाइड्रोजन प्रोडक्शन ऑलरेडी स्टार्ट हो गया है। ऑलरेडी मतलब the target है, government has held initial talks with industry and at least 25 million tons of hydrogen capacity in India is confirmed. वर्ल्ड में तो काफी अच्छा मतलब डेवलपमेंट हुआ है। अगर आप रिसर्च करते हैं, देखते हैं, तो जापान में अराउंड 100 स्टेशंस, हाइड्रोजन के स्टेशंस, फ्यूल स्टेशंस अवेलेबल है। China also cautious about the pollution. उनकी अभी एफसी भी रन हो रही है, जर्मनी में भी पावर ट्रेन्स रन हो रही है। अभी इंडिया में इनिशिएटिव हुआ है, 3 साल हुआ है, 2022 में हमारा नेशनल ग्रीन हाइड्रोजन मिशन बना है और माननीय प्रधानमंत्री नरेंद्र जी मोदी उन्होंने ये इनिशिएटिव लिया है और ये स्टार्ट हुआ है टेस्ट। तो आप ये भी देख सकते हैं इसमें कितनी सारी अपॉर्चुनिटीज मिलने वाली है, जॉब अपॉर्चुनिटीज। ये बिहार में भी अभी एक प्लांट आने वाला है जिसमें ग्रीन हाइड्रोजन का जनरेशन होने वाला है थ्रू इलेक्ट्रोलिसिस प्रोसेस। तो आने वाले दिनों में यहाँ हमारे महाराष्ट्र में, नागपुर में ये मैं समझ सकता हूँ कि ये लास्ट सेशन है और आप सुबह से सेशन अटेंड कर रहे हैं। मैं कोशिश कर रहा हूँ आप लोगों को इंटरेक्शन, ये सेशन इंटरेक्टिव होना चाहिए, क्योंकि मैं यहाँ पे पढ़ाने नहीं आया हूँ, मैं जस्ट मेरा एक्सपीरियंस शेयर करने आया हूँ। मुझे पता है कि मेरे से भी सीनियर बैठे हैं यहाँ पे और आप सभी को आप कहाँ से सर?
गवर्नमेंट पॉलिटेक्निक रत्नागिरी।
So you can see that some case studies now. This already आपने देखा होगा कि हमारे ऑनरेबल नितिन जी गडकरी साहब है, उन्होंने इसका लॉन्च हुआ था 2023 में। तो ये लेकिन कैसा है कि लॉन्च करना और इसको प्रैक्टिकली इम्प्लीमेंट करना, जो आज मतलब मैं बताया कि जर्मनी में 100 फ्यूल स्टेशन है, जर्मनी में आज 100 फ्यूल स्टेशन है। तो हमारे यहाँ पे अभी जैसे जैसे फ्यूल स्टेशन बनेंगे तो ये प्रैक्टिकली फिजिबल होगा। हालांकि टोयोटा ने इनिशिएटिव लिया, मतलब इसमें जॉब अपॉर्चुनिटीज काफी आने वाली है आने वाले दिनों में। अब कितना स्पीड अप करती है गवर्नमेंट, क्योंकि इन्वेस्टमेंट तो करती है गवर्नमेंट इसमें, कितना वो स्पीड अप होता है तो उस हिसाब से आपको आने वाले दिनों में ये हाइड्रोजन फ्यूल पे चलने वाली, मतलब इसमें जो फ्यूल सेल है वो पीएम फ्यूल सेल है। इसमें इसकी जो हमने देखा तो उस पे ये कार्य आपको दिखेंगे रोड पे। बाद में आप देखिए जो जर्मनी में ये हाइड्रोजन पावर ट्रेन ऑलरेडी हो गई है, ट्रायल ली है और रन भी हो गई। तो देखिए कि वहाँ की टेक्नोलॉजी कितने कॉशियस है, हमसे काफी आगे है, उनका पॉपुलेशन भी काफी कम है, हमारे यहाँ पे गरीबी बहुत ज्यादा है, इसलिए टेक्नोलॉजी को इम्प्लीमेंट करना काफी डिफिकल्ट है, क्योंकि रिसर्च में उनका इन्वेस्टमेंट बहुत ज्यादा है। आप जब तक रिसर्च में इन्वेस्टमेंट नहीं करेंगे तब तक एक्चुअल प्रोटोटाइप नहीं बनेगा। क्योंकि मैंने जैसे बताया आपको कि एक सिंपल फ्यूल सेल, सिंपल 5 सेंटीमीटर या 5 सेंटीमीटर का फ्यूल सेल बनाने के लिए उस समय मतलब 4 साल पहले 30,000 रुपये लगे। आज मेम्ब्रेन की कॉस्ट 18,000 रुपीज है, अगर मैं 5 सेंटीमीटर या 5 सेंटीमीटर की मेम्ब्रेन परचेस करता हूँ, उसकी कॉस्ट 18,000 रुपीज है। तो देखिए कितना रिसर्च कितना डिफिकल्ट है हमारे लिए यहाँ पे। मतलब एक पूरे विदर्भ में एक ही लैब है आरटी में, ये पूरे विदर्भ में एक ही लैब है आरटी में। अगर आप नागपुर से हैं कोई, अगर आप इस एरिया में रिसर्च करना चाहते हैं तो आप जाइए सही, आप सिर्फ विजिट कीजिए, जस्ट गो देयर एंड यू मीट डॉक्टर आचार्य मैडम, शी इज डायरेक्टर ऑफ दैट लैब, फिजिक्स डिपार्टमेंट, डॉक्टर आचार्य स्मिता आचार्य। उन्होंने 2 बार पोस्ट डॉक किया है, उनका मेम्ब्रेन पे पोस्ट डॉक है। नो आई एम थिंकिंग ऑन दैट, आई एम जस्ट गोइंग टू रजिस्टर नाउ फॉर पोस्ट डॉक अंडर गाइडेंस। सिर्फ मेम्ब्रेन, जो मैंने आपको मेम्ब्रेन बताया, वो अलग अलग प्रकार की मेम्ब्रेन बनाती है, उनके अंदर अभी 10 रिसर्च फॉलो हो चुके हैं। तो इसमें आप देख कर सोच सकते हैं कि अगर पोल्यूशन को पूरा आपको हटाना है, आज हम देख रहे हैं, तो आपको ये टेक्नोलॉजी को एडॉप्ट करना होगा। बाद में जैसे बैकअप और भी मैंने बोला कि इसको डीसी सेट को रिप्लेस करना बहुत जरूरी है। आज हर कॉलेजेस में, हॉस्पिटल्स में, सब जगह पे डीजल जनरेटर सेट लगे हुए हैं, वो भी काफी पोल्यूशन कर रहे हैं। तो उसको ये फ्यूल सेल यूज करके ये प्रपोजल हम डाल सकते हैं डीएसके में, एमएनआरई में। या इसका कॉस्ट अराउंड 15 लाख रुपीस जाता है एक का, डिपेंड अपॉन कैपेसिटी। अगर ज़्यादा कैपेसिटी का लेंगे तो कॉस्ट बढ़ता है। तो आज के डेट में कॉस्ट भी अगर है, तो हम अगर देखते हैं जो फ्यूल सेल को कंपेयर करते हैं कन्वेंशनल पावर के साथ में, तो आप पिक्चर्स देखिए, एमिशन जैसे मैं बोला कि ऑलमोस्ट जीरो है फ्यूल सेल, और फॉसिल फ्यूल अगर आप यूज कर रहे हैं तो वहाँ पे CO2 भी प्रोड्यूस हो रहा है, नॉक्स भी प्रोड्यूस हो रहा है। एफिशिएंसी फ्यूल सेल की ज़्यादा है ऐसे यूनिट कंपैरिजन में। नॉइज फ्यूल सेल का कुछ भी नहीं, साइलेंट एकदम, और इंजन का नॉइज ज़्यादा है। स्केलेबिलिटी अगर देखते हैं तो फ्यूल सेल की मॉड्यूलर है और फॉसिल फ्यूल की लिमिटेड है। चैलेंजेस भी है, चैलेंजेस जैसे मैं बोला कि हाई कॉस्ट ऑफ फ्यूल सेल सिस्टम्स, हाइड्रोजन प्रोडक्शन एंड स्टोरेज इंफ्रास्ट्रक्चर सबसे बड़ा चैलेंज है। आज अगर ये अगले 10 साल में हमारे यहाँ पे हाइड्रोजन फ्यूल सेल स्टेशन बन गए, फ्यूल स्टेशन बन गए, तो अगले 10 साल में आपको फ्यूल सेल कारें दिखेंगी। तो यही बड़ा चैलेंज है। Durability and material limitations, need for large scale commercialization, or finally this fuel cell, I can say it is a clean, efficient, reliable future power source, and I can also say essential for decarbonization and energy security. So this is your topic. They have given me the topic is green for our future. So I can say lot of potential in this technology. So if you want to ask question, you can ask the question. No problem. I can give in my capacity. I can give the answer. And you can you want help, any help in this research area, you come to me. You just go. You just go to the science direct. Just write my name. You will some papers I have published in that. So you just go to that paper, so you will get an idea that what is the current trend actually, and how many of you completed PhD here? Yes. So other want to do PhD, they are most welcome. I can take 4 students. Recently, I am just supervisor, become a supervisor, and you are most welcome if you want to start your PhD work. I will guide you, and there's a 4 year minimum you have to spend for your PhD research work, and it's up to you how you are doing your research work. But your idea should be clear. आप कहीं भी PhD कीजिए, आपकी आइडिया क्लियर रहना चाहिए, आपका लैब मतलब आपको कहाँ PhD करना है, वो पहले क्या करना है, वो जो आउटपुट आने वाला है वो आपको पहले पता रहना चाहिए, तो आपको आसानी से आपका PhD हो जाएगा। मेरा ये तीसरी बार रजिस्ट्रेशन करने के बाद पीएचडी हुआ है। बहुत से लोग पीएचडी करके छोड़ देते हैं, कुछ गाइड का प्रॉब्लम होता है, तो होने दीजिए, कोई प्रॉब्लम नहीं। But this is my third time that I have registered in my PhD in 2018, and now I got PhD in 2025. First time I was registered in 2009 in real. I left that PhD because of some personal problem. Second time I was registered in 2015. That left. That doesn't matter. It doesn't matter. It's a part of, it's a continuous improvement process. It's continuous improvement process. So you have to choose proper guide and proper topic. And before that, you have to just start the research. Is you have to just start reading the research papers, review papers in particular topic based on the input of your lab. So if you do like this, you will get PhD in 4 years. And here in Nagpur University, 2 papers are compulsory. Scopus journal paper. Nowadays, Scopus journal papers are very important. I don't know whether it is compulsory in polytechnic or not. Is it compulsory? Compulsory?
पॉलिटेक्निक में तो नहीं है सर, लेकिन अभी पीएचडी में तो कंपलसरी है। एससीआई पेपर ही चाहिए मेरे को, एनआईटी जयपुर से है मेरी।
Okay.
वहाँ पे तो एससीआई चाहिए, स्कोपस भी नहीं चाहिए उसको।
Scopus भी नहीं चाहिए।
एससीआई पेपर नहीं होना है।
So then it is easy here in Nagpur. One SCI paper, that is the requirement of our research center. But Nagpur University requirement is 2 Scopus paper.
Okay.
2 Scopus paper, 1 conference paper. If you register at our research center, 1 SCI paper, 1 Scopus paper. That is compulsory. So why I am telling you people like this, because all your faculty members, and what I say, many young faculty are here. Just now, the person who completed his session, he is my student. Diploma, right from diploma and degree, I taught him to Rahul. And now he completed his PhD also. But he is not doing job, he is doing business. So now his mind is very free. When I meet him, because he is doing business, his confidence level is very high. Because he is running his own business. And we are doing a job. So we are under pressure because that is a requirement. अभी कुछ दिन के बाद requirement होगा, compulsory हो जाएगा, and then you will get promotion. Otherwise you will not get promotion. Then we have to do PhD plus some research paper. We have to publish some research paper. This will happen. आने वाले दिनों में ये सब होने वाला है. So you have to just speed up. If you want to do the job, if you want to continue in this profession, you just do the research and just do research with joy. Pension लेके ना. So any question?
Sir, to separate hydrogen, that is the biggest task.
Biggest task. It is biggest task. And
It's in air there is large amount of hydrogen is available.
Yeah.
Air is composed of number of gases. But electrolysis process itself is costly process.
yeah.
So that means any alternative should be there so that we can separate out the hydrogen and then we can utilize in fuel cells or directly in vehicles as a fuel.
Actually, we cannot use directly to the fuel cell. What I have shown you this slide diagram, the schematic view diagram. If you see this, you have to initially split up the hydrogen. Okay, means you have to initially split up the water. That water, after splitting the water, that hydrogen will produce at the cathode, and that hydrogen is, the hydrogen is hydrogen water gets separated here, and hydrogen is stored in the cylinder. And because we need pressure, as I told you initially, we use 0.5 bar pressure in the fuel cell. So however, the pressure is 700 bar here, but we use only 0.5 bar pressure. And for that pressure, we need to store the hydrogen in the cylinder. We cannot use that. So this is just schematic view. There are number of auxiliaries are there. तो ये भी आप कर सकते हैं. ये PM fuel cell. Some people are using alkaline type of electronics, water electronics. तो अलग अलग कैटेगरी है. तो इसमें मैंने जैसे पीएम यूज किया, पीएम फ्यूल सेल को मैंने उसको उसके कनेक्शन रिवर्स कर दिया मैंने, उसके इलेक्ट्रोलाइजर, दैट वाज माय पीएचडी रिसर्च। मैंने एक छोटा सा मतलब, क्योंकि मेरा उद्देश्य था कि जस्ट रिजल्ट्स शो करना। अगर मैं 50 सेंटीमीटर, अभी फिर से मेरा एक रिसर्च हो जाएगा, अगर मैं 50 सेंटीमीटर स्क्वायर लेता हूँ तो फिर से मेरा एक पीएचडी हो जाएगा। अगर मैं 100 सेंटीमीटर स्क्वायर लेता हूँ तो फिर से मेरा एक पीएचडी हो जाएगा। आपको मैं बताता हूँ। ये 500 वाट वाला फ्यूल सेल, 500, ये पूरा जो इतना इतना ही लैब है, वहाँ पे जो देखा तो लिखा है 500 है। ये 13.4 इसमें टेम्परेचर को ऐसा करना है, ये हाइड्रोजन को कंट्रोल है, इसमें ऑक्सीजन को कंट्रोल है, तो इतना ही करंट बता रहा है 29.96। ये 500 वाट का फ्यूल सेल, इसका कॉस्ट अराउंड आता है 8 लाख रुपीस गया उस समय, अभी तो बड़े गया कॉस्ट 8 लाख रुपीस। तो इतना लाभ आप कर सकते हैं। टेस्टिंग स्टेशन है, इसके साथ में ये यूपीएस भी लगा हुआ है, यूपीएस तो आई जस्ट कीप डाटा एग्रीगेशन ऑपरेशन से वैल्यूज में। तो यहाँ पे क्लियरली आपको वैल्यूज चेंज के लिखे हुए हैं, देख रहे हो आप वैल्यूज चेंज के। जब मैं रीडिंग दे रहा था तो ये मेरा ये मैंने चूज किया था टेस्टिंग स्टेशन, जो छोटे फ्यूल सेल के लिए टेस्टिंग स्टेशन। इसका कॉस्ट 30 लाख रुपीस है ये टेस्टिंग स्टेशन। एक्चुअली अगर हम बनाने जाएंगे ना तो इतना कॉस्ट नहीं होगा, मान आपका 5 to 10 लाख रुपीस का है, 10 लाख रुपीस का अगर हम बनाते हैं, लेकिन वो 3 टाइम्स पैसे लेते हैं। तो वहाँ पे फैसिलिटी है, चार्ज 5,000 रुपीस पर डे। तो ये आपको क्या करना पड़ेगा, अगर आपको इस एरिया में रिसर्च करना है तो आपको पहले रिसर्च पेपर ढूंढना पड़ेगा, आपको किस प्रकार का फ्यूल सेल डेवलप करना है, सर्कुलर करना है, किस प्रकार की मेमोरी यूज करना है, वो उनको बताना पड़ेगा। दे कैन हेल्प यू। उनके पास राइट फ्रॉम डिजाइन, मैन्युफैक्चरिंग टू टेस्ट, उसका एनालिसिस। आपने एक बार उनको बता दिया कि मुझे इस प्रकार का फ्यूल सेल बनाना है, मुझे सर्कुलर बनाना है, मुझे इस प्रकार की मेमोरी यूज करना है, मुझे मेरा फ्यूल सेल का ये साइज रहेगा, स्क्वायर रहेगा, रेक्टेंगुलर रहेगा, जो भी साइज आप डिसाइड करेंगे, जो भी एमिंग का एक्टिविटी आप डिसाइड करेंगे, तो उस हिसाब से आपको उनको इनपुट देना पड़ेगा। तो उस हिसाब से आपको, तो वो इंडस्ट्री है, दैट इज रिसर्च इंडस्ट्री, दैट इज रिसर्च इंडस्ट्री। तो एक दिन का वो 500 रुपये चार्ज करते हैं। सो आई हैव डन इंटर्नशिप देयर फॉर 2.5 months। Okay, so any question again? So I hope मैंने ज़्यादा बोर नहीं किया आपको। This last session, that's why I already told you when I compress the session. So any question you can ask me. So my number is there.